know what? Let me write this one more time here. Let me write this. So note that this a plus b cubed is not equal to a cubed and then plus b cubed. Okay, let me write. Fill it in here. This is equal to. Okay, so this is what. Let me fill in the rest of it. This cube. How about this? N power is not equal to a to the n and then b to the n. It is not. It is true when n equals 1. But generally, they are not true. That's what I'm saying. Generally. So generally, not true. Means what? This is what? Generally. Again, when n equals 1, they are true. And a equals 0, that is true too. But those are very specific cases. But this is not true generally. So therefore, square root of 2 plus 1 cubed is not square root of 2 cubed plus 1 cubed. Again, this is actually, this is what I call number 1 mistake in algebra. This kind of a mistake would be a 10-point penalty. A 10-point penalty, you should never make this kind of mistake. Okay? This is now this is a calculus course. Yeah, so I should never see this kind of mistake, ever. In my elementary algebra class, yes, I do allow, and then there will be some points. But for calculus 1 class, you know what, cannot make these kind of mistakes. Again, that will be a 10-point penalty anywhere. Okay, so now let me continue here. What is this? This is equal to, let's multiply these two. If you multiply these two, what do you get? We get 2 plus 2 square root of 2. We get 2 plus square root of 2 plus square root of 2 plus 1. So we end up getting 3 plus 2 square root of 2. I know I'm not going to write every detail here. So we get 2 times 2 square root of 2. We get this. Again, that's going to be 2 plus square root of 2 plus square root of 2 plus 1. So we get this, and then plus square root of 2, and then plus 1. Now, how do you do this? Now, this here, what is that equal to? That is equal to now, if you now do multiply this, what do you get now? This will be 3 times, this is now 3 square root of 2. 3 square root of 2 plus 3. And then multiply this out, what do you get? 2 square root of 2 times 2. 2 square root of 2 times square root of 2, that will be 4. And then plus 2 square root of 2. If you multiply all that, this is what we get. So now if you multiply all this out, what do you get now? This is going to be 7. 7 plus 5 square root of 2. And so this is the final answer. Okay, so again, this is a very, very easy example. This problem might show up on today's quiz or on midterm 0. Okay, so these are, yeah, so now the question is, you got this, we did this now. What's the best way to check in this case? How do you check? How to check? Now, when you check this, usually there are 2 ways to check. A check. You check what? How do you check? Checking. You have this is what? Procedure check. Procedure check. And there's what? Procedure check or direct check. Again, when you check your work, generally there are 2 ways to check. One is called what I call the procedure check, and the other one is what I call the direct check. And direct check is the one which you should do all the time. But there are many ways to check this guy. But now, so in this case, what is the procedure check? What is the procedure? So let me explain to you. Procedure check is what? You check your what? Check your work again. Check your work and check your work. Check your work and look for mistakes. That's what I call mistakes. This is what I call a procedure check. What is a direct check? Check directly. Not your procedure. This is what I call direct check. So in this case here, so let's see, you know what, in order to check this work, what you can do is you can do this. Okay, you can now go back here. So you can now go back and then say this. We have this here, so that is that. Yeah, that is equal to that right there. And then that, when you multiply this out, what is that? That's 2 plus square root of 2. So that is equal to what? That will be 2 plus square root of 2 and then plus square root of 2, plus square root of 2, and then plus 1. And then looks like when you do that, you do get this guy here. And then now, check this guy here, you get 3 square root of 2, and then plus 3, and then plus 4, and then plus that right there. And then you get this right here. So if that's how you check, that's what I call that procedure check. You are checking your form. You're looking for mistakes. And hopefully there will be no mistakes. But generally, when you check your work, usually there's a way to check directly. Usually, a lot of the problems we do in this class, I should say, especially all the problems on intermediate algebra and pre-calculus, you can check your work directly. But you want to somehow check and see whether it makes sense. Now, one way to check is this. Okay, how about check by estimation. How do you do this? Check by estimation. Now, what is this here? Now, what is now? Do you know how big the square root of 2 is? How big is the square root of 2 approximately? About 1.4. About 1.4. So what is this here? So let me now use a different color. How about if I now use green? This guy is about 2.4 cubes. That's about 2.4 cubes. And then now what is this guy about? Well, this guy is about 7 plus the square root of 2 is about 1.4. So what is 1.4 times 5? 1.4 times 5 is about 7. Is it about 7? That is about 7. So what we get is, this is what? About 14. And by the way, at this point, if you want to, you can use the calculator. Can you use a calculator to check? Yes, you can. Again, can you use a calculator to check your work? Yes, you can. Yes, it's allowed. Calculators are allowed here. Like I said, if you use a calculator to actually do the formula, for this problem you cannot do this using a calculator, because as soon as you replace the square root of 2 by 1.4, then that will be a mistake. But can you check using a calculator? Yes, you can. The calculators are very useful when you check your work. And so now, how big is this square root of 2? How big is this 2.4 cubed? Let's look at this. Well, what is 2 cubed? 2 cubed is 8. And what is 3 cubed? 3 cubed is much bigger. 3 cubed is much bigger. And this guy's about 220. This is about 27. Now, 2.4 cubed, where I think it's somewhere in the middle here, maybe about 15 or something, and the answer is 14. Makes sense? Yeah, it makes sense. So there's a good chance that this is correct. At least this is not that much off. If you want to be more detailed, then you can actually calculate this in your calculator and see how much this will be, and it should be fairly close to this color here. And so that's how you check. So what I'm telling you is, use your calculator, use your graphic calculator to check your work. Of course, the best way is to check your work without using any of those tools. You just check your work manually. Okay? So that's what you can do. So again, in this class, if you always many people ask me, do you have any answers to our notes? And the answer is no. I don't have any notes. I have no intention to write any notes. And that's because there's so many problems out there which have answers. That big 300-page worksheet, they have all the answers there. Okay? They have exercises. When you have textbook, when you go through a textbook, they have answers. So you can go through all those. Okay, so now I think some of you might get boring here because I'm going over all the stuff which is too easy to do. Okay, so let me stop here. Okay, so now what I'd like to do is I'd like to get back here. Let's now go back to the material we need to cover. Okay, so now new share here. Let me see. What do we need to cover on these files here? Let me go back. Go to files right here. We have files. Okay, so this one, let me close this. And now what I'd like to do is I would like to go over some of the topics which you need for this course. So 0, pre-calculus rules on testing, I go with that. Numbers and scientific notation. Did I mention this here? Yeah. No, 0002, numbers and scientific notation. Well, I don't think we will have problems on this, but next, numbers and scientific notation, it is actually what? It is a topic on exponents. So, you know what? Just open every file which start with a 00 or 02 or M02 and go through every problem. That's what I recommend. And this is the file. Oh, wait, is that the file? Wait a minute, did I open the wrong file? This is not the file here. Let me see, what file did I open? Numbers and scientific notation. Wait, is this the number? I think I uploaded a different file here. Oh, no, it is correct. It is correct. I think yesterday I didn't go over the second part. I see. It is correct. You know, yesterday I went through the first page and I did not go through the second page here. And the second page is about scientific notation. And so there's a definition right here. So when you have a definition, yes, I want you to read these definitions very carefully, unless you know what the scientific notation is. And then look at these here. And then the question is, can you do these? Can you do all of these problems here? Can you do them? You know what? Should I just do one problem?
Yeah, let's just do one.
Which problem? Now, first of all, you have the definition. What is scientific notation? The scientific notation of a number is the number written in the form a times 10 to the n power, where a is a number between 1 and 10, and n is an integer. Now, n is an integer. N could be positive or negative, but it cannot be a decimal. Is that clear? So n is an integer. So make sure that you understand this language very well. Make sure that you understand the definitions precisely. Now that this is calculus, you are at the point where you must understand these kind of definitions. You have to understand what these things mean. So don't just skip through these definitions here. Don't do that unless you know already. You know what? This is what I recommend. In math, you study once for all. Do not plan to study the same thing over and over again. That is not a good strategy. Again, don't plan to come back again and again and again. That is not the way to study. Try to study once for all. When you study for the first time, when you encounter a term which you do not understand clearly, then settle that issue first. Is that clear? The preciseness is very important here. Make sure that you understand everything very clearly. Like a perpendicular bisector, know exactly what that means. Okay? So there's no hand waving here. Make sure that you know what it is before we go to the next example. So definitions, okay, now here. What is the example 10? Okay, you know what is example 10? Example 10, let's look at it. Okay, example, so let's annotate. Okay, so let's see. Example 10 is going to be, example 10, let's look at A. What is that? That is equal to what? That is equal to now, is going to, the 3 times 10 to 7 and the whole thing cubed. So this can now be written as 3 cubed. And then times 10 to the 7 to the third power, which is 21. Yes, any questions here? So this is the factor rule of exponents. A times B. Anyway, I'm not going to apply. I'm going to write all those rules here because okay. So this is ended. This is now 10 to the 21. Now, do you think that is the number, the final answer, the final number is in scientific notation? Is that it or not? Are we done or not done? So example 10, part A, the problem which I just did, are we done or not done? This is it? Did I get the final answer? Yes or no?
Yes, because it's related to 8 times 10 to the nth.
Right, it is 8 times 10 to the n, right? Yeah, it is. It looks like it is that form, but look at the condition here. Look at the condition. Is A between 1 and 10? We have 27. Oh, that's not it. This guy is not in scientific notation yet. It is getting very close now. And then note the times 2, the 10 to 21. Yeah, 21 is an integer, positive integer, yeah, but 27 is not a number between 1 and 10. So we have to make an adjustment. So this is going to be now, let me put this in parentheses, let's go to 2.7. So from 227, we change that to 2.7, and then times, now the question is times 10 to the 22, or is it 10 to the 20? Should the exponent be 22, or should the exponent be 20? Now, from 20
22.
to 27 to 2.7, did the number get smaller or bigger? The number got smaller or bigger? The number got?
Smaller. It got smaller.
Number got smaller. Smaller by 1 decimal place. This number got actually smaller by 1 decimal place. Actually means that it got smaller by factor 10. That's what it really means. But I call this, it got smaller by 1 decimal place. Therefore, this number right here now must get to the other party. This is a product here. So now this guy right here must get bigger. Must get bigger by 1 decimal place because the other guy got smaller. So the answer is now 22. So the answer is now, you know what, let me rewrite this here, 22. So the answer is 10 to the 22. So this is it. So why is this called scientific notation? Because if you take any science class, physics or biology or physiology or astronomy or whatever science you take, whatever science class you take, you know what? And then they have numbers. They like to write the numbers in this form because it is easy to see, easy to compare, and so that's what they do. So hence the name, the form of this number is called scientific notation. So scientific notation is not a specific number, it's the way we express a number. This is called scientific notation. Okay? So anyway, we have all of these problems here. How about like there are many problems here. Example test 11, 12, and you know I can scroll this down, and then let me erase this, and now let me scroll this down here, and you have all of these problems here. Yeah, you know what, this right here, yeah. So all of you, yeah, you should be able to handle these here. Okay? Any of these problems might show up on, I don't think I'm going to give you this problem today, but it might show up on midterm 0 on Friday. Okay, and that's my target date for midterm 0. Okay, midterm 0 will cover all the entire intermediate algebra and pre-calculus, but it will be focused on things which I mentioned in class. But a lot of the basic topics, even if I did not mention in this class, will be covered. Okay, so if you look at this guy here, let's say, you know what? Don't have too much time, but should I do one more? Oh yeah, I can do one more. Let's say, how about part F? And you know what? Do this on your own. All right? So I have to do this. You know, okay, maybe I'll show you one. Okay, maybe I'll do one for you. Okay. So let's look at how about let me do. Okay, which problem do you want me to do here? I'll just do one more for you. Or do you want me to skip it? Or do you want me to do one more problem here? Any of you?
One more.
I'll just do one more if you want. Otherwise, I'll skip it.
Could you do
F?
F?
Do you want?
Yeah.
Okay. Example 12F?
Yes.
12F, right? Okay, so let's look at 12F. Okay. So let's look at 12F here. Okay, so 12F, I want to maximize my space here. So let me, okay, so this is 12F. Okay. So let me do 12F. So annotate, and so now let me do this. So what is this right here? Okay, first of all, well, this is 1.2. Now, when I see a decimal, everybody's different, but I like to convert all of these decimals into a fraction. That is my style. Everybody has a different style, but I think fractions usually tend to be easier. So let me do that. So what I'm going to do is this is not 1 times 2. This is 1.2, and that will be 6/5. I'm going to write 6/5 right here. 6/5. And then what we have here, and then times. Let me write all the powers of 10 on this side. So let me write 10 to the 11 over here. This is all product here. Note that part F, the good thing about this this problem is, this expression is that everything is multiplication here. And then now we have 5 here, so let me write 5 here. Note that this is now, I can put a 5 here. And then times 10 to the minus 8. I can put 10 to the minus 8 over here. Separate them. That's what I did. 10 times 10 to the minus 8, and there's no exponent. And then times 2 times 10 to the minus 3 to the third power. Now this part right here is 2 to the third power times 10 to the minus 3 to the third power. Again, I'm applying this rule. One other rule which I like to apply a lot is going to be this rule. A times B times C, A times B times C over D times E. And then if you have this whole thing, this is a product here. Product is all product, and then this whole thing to, let's say, the n power. Then now, what is this equal to? This is equal to what? This is equal to a to the n power. This is a to the n power. And then a b to the n power. Oops. You know what? This n is not showing up. Yeah, this is b to the n power. And a c to the n power. And this times c to the n power. And the d to the n over d to the n power. And then e to the n power. This is one of the rule which I like to apply, on these kind of examples here. Again, everybody's different. If your solution is a little bit different from the way I do, that's okay. Again, if you present a different solution on the test or quiz, I will accept them, provided that it is logically and true, logically correct, mathematically and logically correct, and you show me enough procedure. As long as you show me enough procedure, your solution does not have to be exactly the way I did in class. As long as it is mathematically consistent, logically clear, I will accept them. Is that clear? So this one, yeah, so this is going to be now times what? Times 2 to the third power, and then times 10 to the minus 9. So I can write 10 to the minus 9 right here. So I like to separate all the numbers and all the powers separately. So what is this here? So this is equal to now, 6 over. What is this? 5 times 2, 5 times 2, this is 200. Not hard to see. Then times, this is 10 to the 11. And then times, this is 10 to the 8. Minus 8 in the denominator can come up and make it become 10 to the 8. And then times, how about 10 to 9? Okay, that will do. So what is this? Can you reduce this? Yeah, we can reduce. Can you reduce this? Yeah, we can reduce that. This is actually going to be 6 over 2. How about this? This is going to be 3 over 100. And then times 10 to what? 28. Okay, now there are many ways to do this. How about if you write this as, you know what, now this one here, you can separate this 10, 100 here. How about if you just write this as 0.03? 0.03. We'll just use a decimal here. 0.0. By the way, in scientific notation, usually the number part is usually written in decimal. So in this case, you can write it this way. 10 to the 28. Are we done now? Are we done now? Is it the end, or do we need to have one more? Do we need to go more? The final answer is that in scientific notation or not?
Yes.
Is that it? Yes or no?
No, because it's not between 1 and 10.
Right. This number is not between 1 and 10. Also, this number is an integer, so that's a good thing. If this guy is a decimal, not an integer, then of course that you have to adjust that too. In this case, 28 is an integer, so that's fine. Now this one is not. It's not, that number part is this guy is not between. So now we have to make an adjustment. This is 0.03. So it looks like we have to make that into a 3. So when you write that as 3, then now the question is now 10 to the what? Now the question is now, you know what? When you make an adjustment here in scientific notation, don't go by left and right. The left and right argument is forever confusing. So don't do things like this, like 0.03 and then 0.03 and then this right here, and then you move the decimal here and there. You know what? Don't do these kind of things here. Very, very confusing. very easy to make a mistake. So in this case, 0.03 to 3, did the number get bigger or smaller? This is 1, 2, and the number got bigger. Bigger by what? Bigger by 2 decimal place. Bigger by 2 decimal place. Now when I say the number got bigger by 2 decimal place, that means the number grew 100 times. So got bigger 100 times. That's what I'm saying. Okay? So the number got bigger 100 times, or I say it got bigger by 2 decimal places. And because this guy got bigger by 2 decimals, to compensate, the other guy must get smaller by 2 decimal places. Smaller. And so in this case, what would that be? That will be 26. So it is much better to apply the smaller, bigger argument. The big, small argument is much better because when you see this number 0.03 and 3, we know immediately that this number 3 is bigger. We can, it's in our brain. It's very easy to recognize whether the number got bigger or bigger or smaller. But moving right or left is forever confusing. So do not apply forever, right or left, and do not, draw these kind of waves here. That is something you draw in your art class, but don't do this in your math class. Okay? It's forever confusing. So now everything is correct. Now in this case, there's really not much to check. Okay, but anyway, this is it. So this is the final answer right here. Anyway, you know what? I think I've done enough examples here. Again, I want you to skim through all of these examples here, and then what? And then you skim through all these pages and do them. So you look at it. If you think that you can do it, then you skip it. That's what you do. All right. So that was the file number 0.0002. And then I talked about the two special triangles here, and then parameters, I did that. And then 0005, a blank graph. This is really nothing. It's just this. If you need some graphing paper, that is. Yeah, it's just this. Okay, there's nothing much here. This is the graphing sheet here. If you need some graphing, okay, that's all. But now you use a calculator, so I don't think you need. Anyway, that's a blank sheet. There's not much there, okay? But you know what? However, all the files start with 00 or 02 or M02, open up and check it out, okay? Check everything. And if you think you know this or there's nothing to do, then you skip it. But don't skip anything, okay? That's my advice. Don't skip anything here. So now, so what is this here? Line equation, yeah, we did that already. And the evaluating function, we did that. And then polynomial division, each function, okay, you know what? These guys here, why don't you look it up too? No, these guys here, okay, polynomial division. You have to know this? Yes, you have to know this. Polynomial division here. And all these terms which I mentioned yesterday. Long division, synthetic division, this here. By the way, on this page, I did not show you an example of any long division, synthetic division. Please look at other textbooks, like online textbooks. You can see that. If you want me to do an example, I can do it for you. But you know what? Let me just go through. This is all intermediate algebra. All of these stuff is about 2 courses behind, below this course. So you know what? I don't think I need to spend too much time here. So make sure that you know long division, synthetic division, all these things here. And if you have any questions, you can bring it to me. But please try all of these problems and make sure that, you know what, when you look at these problems here, you don't have to do all the problems here. Don't do all of these problems here. But make sure that you can do it when the time is given to you. So you look at this, and then if you think that you can do it, then you skip it. That's what you do. Now, I don't know the answer to any of these here, but if I'm given the time, if I'm given 1 minute or 2 minutes, then I can do this. Now, example 1 and 2, yeah. Example 3, I can do that by synthetic division. Example 5 by synthetic division or by long division. Example 4 must be done by long division, so that one might take about maybe 2 to 3 minutes, about 3 minutes. But example 3 and 5 will only take 1 minute. Example 2, well, you can do that by synthetic division with adjustments, or you can actually do this by long division. So let me just write it down. This one, you can do this by long division, by synthetic division, synthetic division, or by synthetic division. This is easier, of course, easier and faster. Okay. It's basically this is easier and faster. And or now if you do, can you do this by long division? Yeah, this is by long division as well. Long division. By long division, this is what? Oh, that's longer. Okay, it takes more. Now, if you look at example 4, this one you cannot do this by synthetic division. So this one, by long division. By long division, cannot apply synthetic division. Now, if you look at example 2, you can do this by synthetic division with adjustment. Or you can do this by long division. So, oops. Let me, by synthetic, you know what, let me just do this again. So let me write this again. This is by or you can do this by long division. Okay, you can do it either way. Example 5, you can do that by long division. So it's by synthetic division. And so if you do the problem by synthetic division, they only take like a minute. And so we have this. Okay, so we have all this here. Let's see. Would you want me to do one? Would you want me to do just one problem here, or can I just skip it? Now, I'm a little bit afraid that I'm spending too much time on the relatively easier stuff here, which you have to know. They're all covered. You have to know them. And these guys will show immediately, by the way, all these topics here on synthetic division and long division, they will show immediately when you start chapter 1 in our course, in calculus. In calculus, you start in chapter 1, these guys will show up immediately. So these are all the things which not only you have to know, but they will actually show up in our course, in the earlier part of the course. I am not doing a general review of intermediate algebra pre-calculus. I am trying to focus on topics which you actually need in our course. Is that clear? I'm not interested in giving you the review of the entire pre-calculus. That's not my interest here, okay? But more or less you have to know, that's for sure. But I'm focusing on things which you have to really know, all right? And these guys you have to...
Could you show us an example for one of these, please?
Okay, how about this? You know what, the long division is the longer one, but I want you to learn it on your own. Let's do the synthetic division, which is much easier. So let's do it, okay? I'm going to do the easier one, and I will let you review or study the other one, the long division, on your own. Again, type in long division on your internet, and then you'll find a lot of examples. Or go to the online textbook, or you can again go to, or you have any textbook, any math textbook, any textbook on intermediate algebra, you will see long division. Again, any textbook on intermediate algebra. A pre-calculus is already above the topic, therefore there's a good chance that you will not find it. You know what? You may find it in pre-calculus too, in pre-calculus or intermediate algebra. They are long division. Okay, so now here example 3, let's do it. So this one, let's do it by synthetic division, by synthetic. Okay, solution by synthetic. When divisor is x minus c. Okay? But c may be positive or negative. C may be positive or negative. So even though I write x minus c, it does not mean it's x minus something. It could be x plus 2. It could be x plus something or minus something. So we generally write x minus c instead of x plus c, because if you write x minus c, then what we call the 0 or the critical value is x equals c. That's why we write x equals c instead of writing x minus c. So the divisor, what is the divisor? The divisor is the expression which we divide by. So in this case, first of all, the divisor is x minus c right here. The bottom, this guy right here, is polynomial, is a linear polynomial x minus 2, and that is in the form x plus or minus something. So therefore, in this case, the synthetic division is applied, can be applied. So we are now going to apply the synthetic division. That set of the synthetic division is going to be 1, 0, and then 0, x to 4, 0x cubed, 0x squared, and then 4x, and then 1, and then we are dividing by x minus 2, so we are going to put a 2 here. Now this is the setup. This is the synthetic division. We have now done the setup. So we are now ready to apply the synthetic division, but before we apply it, this is how we write it. Now that everybody understands where these numbers are coming from. Yes or no? Do you have any questions here? Well,
The 2 comes from x minus 2, correct?
yeah. When you divide by x minus 2, then this 2 right here is the value for x, which will make this equal to 0. Therefore, when x equals 2, then we get 2 minus equals 0. That number is going to be put here. So if you have x plus 2, then you have minus 2.
But the zeros are the missing degrees between the 4th degree and the 1st degree. Is that right?
Exactly. That is exactly right. So that's in fact one of the mistakes. This is 1x to the 4th power, and then plus 0x cubed. And so every degree term must be present here. So we need a column for every degree. So that is going to be plus 0x cubed and plus 0x squared, and then plus 0x squared, and then plus 4x, and then plus 1. So the numbers we see in there, the 10041, they all represent the coefficients starting with the highest degree. So 1 is the leading coefficient, and then all the coefficients, and there cannot be any missing degree column. We need a column for every degree. So this case 10041, exactly that's where the zeros are coming from. That's right. So if you do, let's say, example 5, that would be 1, and then 3, and then that would be 0, and then that would be negative 4. The constant also we need a column too. So we do this, and then this would be 1 right in this case. Multiply 2 by 1 is 2, and add those two numbers, we get 2. And then multiply 2 by 2 is 4. And then add the two numbers, 0 and 4. We are adding, not subtracting, until we get 4. And then 2 times 4 is 8. So put 8 here. And then add those two numbers, we get what? We get 12. And then multiply those two numbers. 2 times 12 is 24. And then 24, we add those two numbers, and we get 25. And the last number, 25, is actually the remainder. So in this case, I'm going to put up like a separate, I mark it like this. So to show that the 25 is actually remainder. Now, this one right here was 1x to the 4th power. That was the highest coefficient of x to the 4th power. Apply when you after the synthetic division, this one is the coefficient not for x to the 4th power. It's actually 1 is the coefficient of x cubed. So now we are ready to write the final answer. The final answer is going to be written in the divided form. It's going to be this. It's going to be this. And then plus the remainder, this. And then the divisor. This is how we are going to write the result. So this is the work for the synthetic division, but after it's done, you don't stop here. You have to write the result. And writing the result is always important. So what is the quotient? This part is called the quotient. It's all explained somewhere in the division. Well, 1x cubed plus 2x squared, and then plus 4x plus, am I running out of space here? I should already know 4x, and then what? Plus, and then plus, yeah, I barely made it. Plus 12, okay? Yeah, I should have written a little bit smaller on the left-hand side, but anyway, that's that. And then, what is the remainder? Remainder is 25. And then, what is the divisor here? The divisor is x minus 2. If you write like this, you get perfect credit. And of course, for terms such as long division, what is going on here? I cannot write this. Okay, there we go. This is x. Let me erase this part right here. Oh, so what happened? Let's just erase that part. Okay, that's okay. X, and there was minus 2. So that's how you write the divided form. If you want to know what is going where, then you can just look at example 1. Example 1 is a numerical example. If you do 18, if 18 divided by what? 7? This one everybody can do. That is what? That will be, in this case, what? 2. Oh, this is actually more like long division. Anyway, you know what? That's okay. I'm not going to make any more comments, okay? So I think I don't need to. Okay, any questions here? So that's the final one. Now, long division is a different method. Long division is a different method. You know what? I don't want to spend time here at this time, so I might do this, but please, how about this? Well, those of you who do not know long division, please study long division on your own. I think some of the stuff you're responsible, so you have to, you know, and then you study long division. Long division if you don't know. If you don't know. Okay? If you don't know. The long division, let me just write the first step. If you do long division, this is what you have to do. This right here. And then 2x cubed. This now I'm doing example 4 here. Example, this is 2x cubed, and then plus 7x squared. Oops, you know what? Now we have 7x squared. And then 0 is missing. You know what? Plus 4x. And then plus 1. And then divide by x squared. And then what? Minus 3x and then plus 1. That's how you divide. And then the first term is going to be, we have x cubed. And this one is 2x cubed. This is x squared here. And this is 2x cubed. So we would actually write x over here. Oh, you know what? I made a mistake. This should be 7x squared. Why did I write 7x cubed there? That is a mistake. So let me erase this guy. Okay, so that will be square. So this is 1. And then you write the x here. Can you write the x here? Now some books, they actually write the x over here. Now if you write the x here, is that a mistake? No, it is not a mistake. But the columns, the degrees don't match here. So writing this x over here is not, you know, it's not good. But I even find some textbooks doing this, okay? But anyway, it's not wrong, but it's a matter of style. But this, putting the x over here is actually better, so that each column will have matching degree. So that is the way to go. It's like this. If you have, let's say, let's say have 18 divided by 7. If you have 18 divided by 7, and then if you write the 2 over here, is that a mistake? Instead of writing the 2 over here. So 18 divided by 7, and then writing the 2 over here. Now all of us, of course, we write it this way. We write the 2 above the 8, because this 2 is basically 2, 1. That's why to keep the consistency of these number of places, the 2 should be right above the 8. That's what everybody does. But if you write the 2 here, is that a mistake? No, this is not a mistake, but nobody does it this way. So it's not wrong though. It's not wrong, but it's not wrong. Mathematically, it is not wrong, but you know it doesn't look good, and we don't know what the end is. Here, if you put the 2 here, then we know that is the end. So here we want to put the x here and not the x over here. So we want to put the again not x here but x over here. Okay? It is a matter of style. But again, I have seen some textbooks putting the x over here, which I think is not good. But again, it's not wrong. It is a matter of style. In this class, you only get deducted. There's a penalty only if it's wrong, not when it's ugly or inconvenient. You never get a deduction for that. However, if it's not the simplest way you write, then there's a good chance that you'll make a mistake. And by the way, for example 3, when you do long division, it's going to look like this. It's going to be x to the 4th power, and then you put a dot here and a dot here, and then plus 4x, and then plus 1. 4x, and then plus 1. I'd actually just put a dot there, showing that there's a space. Otherwise, if this is too confusing, you have to write plus 0x cubed, and then plus, oops, you know what, how come this thing is not working through? Plus 0x cubed and plus, and then 0x squared. So you do need these zeros, these terms here, whether you do long division or synthetic division. And then you write over here, you write what? X minus 2. And then what is it? X here and x to the fourth here. So x here and x to the fourth here, those are the high degree terms. So what is the first term in the quotient? So whatever goes here will be the quotient right here. And the first term you'll see is going to be x cubed here. Anyway, I will let you do the rest, okay? I will let you do the rest. I cannot do everything here, so I will let you do the rest of it. So let me just take a screenshot here, and then clear all this. And then it's time to say goodbye to this page. Oh, by the way, yeah. Example, if you look at example 6, find the constant k such that x cubed minus 5x plus k is divisible by x plus 3. So let me make a comment of this. Let me make a comment on this. Is now the term divisible?
Professor, I had a quick question.
Yeah, what is the question?
Are these pages accessible like after class?
This one? Yeah, this is a file on our notes.
Okay, this is my first